So at 1,800 miles, the motorized bike engine finally let go. And I guess I deserved it because I was in the middle of riding a wheelie. And what's important to save a motor, if it's even possible, is when your motor blows or dies, don't try to restart it. I turned my motor over a little bit and I noticed I have no compression, but it doesn't seem like anything's stuck. So, assuming the worst, it sounded pretty bad, so we're going to go ahead and pull the head off here and take a look downside. Alright, so I got the head bolts off here, and you're going to see it at the exact same time I'm going to, so go ahead and work this up and off. Sure enough, I think it grenaded the wrist pin bearing. I'm going to grab a light here. Can't really see, but the side of the jug has a real big score in it. Okay, so here's the bike all disassembled. Now this is pretty simple. It took me about 10 minutes just now. All you do is you got your piston here and your wrist pin, and you have these little clips here, and you just grab onto those with a pair of needle nose pliers and twist and pull them out. And then this is kind of interesting. I had to kind of use this little pin here and put it in there and beat it out with the back of my socket. But anywho, I'm going to knock it all the way out and hang it from a mirror in one of my cars. This is actually the first engine failure I've ever had. But taking a look at the rings, obviously, we'll start here. Obviously, we have a problem here where we had some obstruction that just destroyed the side of the piston. Now, anyway, so we can see that by looking at the top, it looks like a lot of carbon, but this is 1,800 miles of riding, and that's actually pretty good color. And here's kind of the head. Now it looks like a lot more carbon than there is there. The spark plug is a good color, a nice tan color, so it was really running well. But what I can see here is I started to get some wear on the inside of the jug. Now you can't see it super well, but where my finger is in here, there's actually a crack, and it cracked from this intake port all the way up to the top of the cylinder. You kind of see it ever so slightly right there. So anywho, I believe that the crack is what happened first, and then it just destroyed the side of the piston, stuck the ring in there real good. And once that happened, then I had a no compression situation. So I made sure I shut it down really quick, and that's why this is so important. Or else I would have kept rubbing, and all this material would have fallen down inside the engine. Now this engine was still running after I came out of the wheelie, and it didn't sound right at all, so I shut it down, didn't try and fire it again until I pulled it apart. So it only ran like this for about 2 to 3 seconds before I totally killed it and had the clutch in. So anyway, you can see that that's obviously kind of a problem, so I'm going to go ahead and replace my piston and my jug and all that. The bottom end, I might pull it apart to make sure no particles went in, but rotating around, it doesn't seem like there's anything, but I'll definitely take it off and turn it upside down, see if I shake it around, see if I hear anything inside there. I originally thought it might have been my needle bearing that shelled out, but it's actually in really good shape. So I wanted to take one final look here at all of our blown motorized bike parts. So this is the cylinder. You can see cylinder wear all the way around the piston, and then or around the cylinder wall. You can see here where it failed. I believe I snapped a piston ring, and it wedged itself in there. Because when I pulled the piston out, I had a broken ring, but it could have broke after. Whatever happened, but something between there failed. So anywho, that's what the jug looks like. Now here's the piston itself, a real close look. You can see that I was having a lot of blow by there. the rings looked like they were on their last leg, and these are just iron rings on these bicycles. Now that I took it apart, I could get a good look at them. And iron rings are about the lowest quality rings. They only last about 80,000 miles in a car, and with a two-stroke turning up above 4,000 RPM most of the time, usually around 5 to 6, they don't have much of a life at all. So this one died at 1,800 miles, and I really used my throttle quite a bit, so it was pretty tired by that time. But you can really see the blow-by here on each side where the wrist pin slides in, and that's actually where it failed, where I had a ton of blow-by, you can see. So I believe it was something to do with the rings, and they seem like they're all burned up. Now I wasn't running too lean, as you can see. I showed the head earlier, and my spark plug was a good color, but you can see a fair amount of carbon on top of this piston head, and it really shows that, you know, if anything, I was running the engine on the rich side, so I always like to run on the safer side of things. Now here's the interesting thing I didn't expect to find. So here's the wrist pin, and I don't know if we can see it real well. You can kind of see that line across it. Now that's a machining divot. Now there's multiple of these all around. You can kind of see them all around the wrist pin. Now when you slide onto the needle bearing and spin the needle bearing, you can feel those in the rollers. So I'd have to say that that's, you know, factory error there. You shouldn't have that. And I have another wrist pin upstairs, and it's not like this at all. So, you know, you can really feel those with your fingernails, and those rollers, definitely, you can hear them chatter when I just roll it over it, and that didn't happen from riding it. That was how it was to start with. So pretty poor quality. So that's something to look into, your wrist pin, if you ever have your jug off. But anywho, that's a close look. So remember, you only have iron rings. Most cars today run moly coated rings, so iron rings are pretty low grade. So anywho, there you have it. Blown engine. So I got all my parts in to rebuild the top end of my motorized bike. If you've seen my other video, I rode 1,800 miles, and then the rings gave away and kind of messed up the piston in the jug. So I got a new jug, a new piston. The bottom end is all stock, the original stuff. So anyway, what I noticed when I was kind of mock fitting this all together is that at top dead center, which we're at right now on the engine, you can see in there a good portion, a solid 1/5 of the intake port is blocked off by the piston. And I know that I have it correct because your little arrow here needs to point towards the front of your engine, or if you have your engine some funny orientation, this arrow needs to point at your exhaust port, which is this side over here. So anyway, I'm going to go ahead and mark that, and I'm going to go ahead and grind it off so I get better intake, a better intake area there, because you can see that blocks off some of the intake flow. And I got my gasket on here, my old one that's already pre-crushed, so I know that everything's where it should be, and this is at the very top of its dwell. This piston here, so we'll go ahead and make a mark and then pull that all apart so you can get a look at that. And I'm going to go ahead and grind it off. I wanted to make a note here that whenever you disassemble, usually this wrist pin is in here a little tight. So what you want to do is, if you plan to reuse your piston, is to put a rag in here in between your head studs and your piston, but still allow area to punch that wrist pin through. so that you don't damage your piston on these head studs. So I went ahead and knocked it through just like that, so it should be as simple as grab it from the other end and then she's all apart. Okay, so as you can see, I marked off here where the piston was covering the intake port, and considering how big that intake port is, which is only yay big, you know, that's a decent amount when you got a piston turning at 5,000 RPM, so that's pretty fast, and that limits some of the flow. So before I reinstall this, I'm going to go ahead and grind it out. So, and this will definitely be a problem if you have anything that's a bigger spaced gasket here below the jug. You'll have to grind more out. So that should help performance a little. I'm going to go ahead and do that, and then we'll check back. Okay, so we're getting ready to put the motorized bike back together now and rebuild the top end. So I got a new jug, new piston, new rings, new wrist pin bearing and wrist pin, and E-clips. I went ahead and cleaned all the carbon out of the top of my head, so we should be good to go here. First thing you want to do is make sure all your gasket and mating surfaces are clean. I went around this one with carb cleaner, so you want to make sure that there's no oil or any residue of that nature on that surface so that everything will seal up real good. So, and you want to always use new gaskets. So I'm going to go ahead and slide that on, and then we'll go on to inserting the piston. Quick note here to make is I had to cut out along this edge of the gasket so it didn't obstruct the flow on the intake port from the crankcase to the jug. So again, we'll go ahead and get the piston on here. Okay, so we got everything hooked in there, and how it goes is you take your wrist pin bearing, set it in your rod, and then you set your piston over it and push your wrist pin through, and then you take your little clips here with needle nose pliers, and you'll squeeze them and put them in and turn them in, and they'll pop in. They have a seat, so you know when they're in. You want to rotate them, make sure they're into their seat, and again you want to make sure this arrow is pointing towards the front of the bike, or if you don't have it on a bike, towards your exhaust port, which is over here. So that's opposite of the side that your carburetor's on. So anyway, and you want to make sure you have a rag down here so that you don't drop anything into the crankcase like these little clips, because that's real easy to do. And then pretty much you're ready to set on your jug. I make sure I give everything a good oil bath before I insert it, so those the bearing and the connecting, or the bearing and the wrist pin, excuse me, I had them good and oiled up before I slipped them in there, because it's just good practice. I also have a relief that I did in the back of my piston with a file, so that at top dead center it doesn't partially cover up my intake port here, so that'll be good. So we'll go ahead and slide the jug on here, and I'm going to oil up the cylinder wall so it slides on easier. And you can just compress these rings with your fingers when you slide it on. Something to look out for is these rings actually have a seat, and they're actually both on the other side. It's like a little pin that comes through, and oh, there's one right here. So it's a little pin that comes through, and that's right where the you can kind of see the pin, and that's where the ring's supposed to meet. And so, because these rings aren't supposed to rotate, because they can get caught on the cylinder ports here. So I'm going to go ahead and compress these rings with my fingers and slide the jug on. Obviously, you'd compress the top ring, get it slid over, and then you compress the lower ring and slide it over. So again, I'm going to go ahead and oil that up so it makes the process a lot easier and doesn't damage anything. So here we go. I also wanted to mention that it makes everything a lot easier to bring your connecting rod to top dead center before you start trying to install everything. And I removed this cover here so I could just turn this and put it to top dead center and then let out my clutch, so the wheel is holding it in place so it shouldn't go anywhere. So again, that makes things really easy to install and assemble, and especially when you go to slide this jug on. And just like that, it slides on. So again, I compressed the top ring first, slid the jug on over the top ring, and then compressed the second ring and slid it the rest of the way. So it's a little tricky and a little difficult, and you want to make sure you get that the opening right where that pin is. You don't want to get anything binding up. So after you get it on, thought it would be good practice to grab down here, let out your clutch, and see if it'll turn. So mine turns pretty good, and you can feel the friction in the rings. So when it runs, they'll seat, and they're just iron rings, so they should seat pretty fast. I'll turn it over here, bring it to top dead center. Oop, a little bit past. Right there is pretty close. You can see now that when we look in here, after that's been cut out, that part of the piston doesn't show. So you can see there it is, and then oops, we can get it to rotate, and there's top dead center. So you can see that would be covering the intake port. So I went ahead and ground that out. I marked it with a Sharpie and then cut it out. So anyway, we'll go ahead and install the rest of everything. From here it's pretty simple, just slap on and go. So the next step is to install the head, and what I do is I put a little oil on the threads of the head studs so that when I torque down my bolts I get an accurate torque spec. I've been kind of lazy and I keep forgetting to change these or pick up different ones at the hardware store, but I recommend getting some different nuts instead of these Acorn nuts. They're not as good. You don't want anything that's a locking nut, because then you can't accurately torque it. And the torque spec on these head studs is 12 foot-pounds, I believe, so not a whole lot. And you want to go in a crisscross pattern. You want to do it usually in a 3-step process, so you'd go like, I don't know, 4, 8, 12 maybe. So you do all of them to 4, then all of them to 8, and all of them to 12, and that prevents head warpage. So you do that on any type of head that you're torquing. So anyway, once you're at this point, now it's just attach your carburetor and your muffler, and you're good to go. So seems like it's doing its job. Nothing's binding up, and that piston isn't covering up that port, so that's good. There we go. You can see that it clears. So that's something to look into. But anyhow, so I'm going to go ahead and reassemble the rest of it, but overall the top end is a pretty easy job. Alright, and just like that, you're reassembled and you're ready to rock and roll again. You always want to use a new intake and exhaust gasket, but if you don't and you reuse it, the exhaust gasket will usually be fine, but the intake gasket will usually benefit from a very light coat of gasket sealer. So that helps to keep it all sealed up after it's been compressed once. And then on my cover here, where the CDI or whatever it's called, the coil is at, or the magneto, there we go. You always want to make sure to have that good and sealed up, because if any water gets in there, it'll kill these motorized bike magnetos right off. So I took my gasket off, and always you want to wipe it all down from all oil and grease so your gasket sealer will work. And I put a light coating on both sides of the gasket and put her back on there. So that should keep that good and sealed up from any rainwater that I may go through. So anyway, there you have it. We'll go ahead and go fire up, but that's how you pretty much rebuild your top end. It's real simple. Anyone can do it. Alright, so I got the bike all back together, obviously, and it runs good. I did change my plug boot and plug clip-on assembly over from some old Ford plug wires I had laying around, so that seems to do a lot better. I'll go ahead and fire it up, but it runs off real good. See if I can hold the phone and do this at the same time. If I drop it, oh well. And we're off. There it is.